Hey, what's up? It's your old pal, Mr. Cook, and we're going to go through the quiz review page by page. Let's see here. So starting off with the very first couple of problems, name each polynomial by degree and the number of terms. So the degree is really easy and the number of terms is really easy as well. And then we can also state if it's not a polynomial if we need to. First, let's talk about that part. If it's not a polynomial, you'll see the following things. If you have some expression with x in the denominator, it doesn't matter what it is, if it's 3x plus 5 or whatever, if it's in the denominator of some fraction, and it doesn't matter what's on top of the fraction, like any number or whatever, then since you have the x in the denominator, this is not a polynomial if you see that. Another thing is if you see an x value with a fraction exponent, like 4 over 3, then this is not a polynomial. And then the last thing is if you see an x value or some expression of x underneath the radical, then this is also not a polynomial. So look for those kind of things to tell if it's not a polynomial. Most of the time we're going to, when we test you or quiz you on something like this, we will have a polynomial for you to, work through. So just watch out for those three things in case, you spot them. That's what makes, something not a polynomial. These are both polynomials, so I'm going to talk about the degree first. To tell what the degree is, all you need to do is just find the x value that has the biggest exponent, like, a 5 or a 6 or a 7 or an 8 or a 3 or a 2, whatever the biggest exponent is, and that's what your degree is, okay? Now for the number of terms, that's how many monomials are separated by addition or subtraction. So all you have to do is just underline all the numbers that are separated by addition and subtraction, and that tells you how many terms that you have. So for this first polynomial, this is indeed a polynomial because it's one monomial, and it just has one term because it's just one number there, so that's going to be the number of terms. So terms equals 1. And then the degree on the variable with the biggest exponent. Well, there is no variable on there, so that means that the degree is, as you might imagine, 0, because there is no variable and there's no degree. On the second one, we have 2 terms, because it's two numbers separated by subtraction or addition. So there are 2 terms on this one. And then the degree. So the degree is the biggest exponent on the variable. So the variable x to the third, and then this variable x has an exponent of 1. So 3 is bigger than 1, so that means that the degree on the polynomial is equal to 3. So pretty easy stuff there, and we're all done. With simplify any expression, all we need to do is just add or subtract, and what this secretly means is just to combine your like terms. So what does combine like terms mean? Let's work through a couple of these and decide what that means. So when we combine like terms, we first look at the sign that we have in the middle. So since we're adding, we can just get rid of these parentheses. So 7n to the fourth plus 8n minus 6n squared plus 2n squared plus 2n to the fourth. So when we're combining like terms, we combine the terms that have the same exact variable and exponent. So for example, if I start with 7n to the fourth, I have another n to the fourth over here at 2n to the fourth. So I add together the two coefficients. 7 plus 2 gives me 9. So that means that the first thing that I would combine are those, and I'd get 9n to the fourth power. The next thing I'm going to do is the 8n. So if I have an 8n, I have another n over here with plus 2n. So if I have plus 2 and plus 8, that adds up to a positive 10, so 10n. And then finally, I've got a negative 6n squared and a positive 2n squared. So what I'm going to do here is just, since I have the the negative 6 and the positive 2, since I have these 2n squareds, I just take 2 and subtract away 6, and that gives me a negative 4n squared. This is now my simplified polynomial expression. Just combine the like terms. I can't combine them any further because I don't have any more n to the 4s to add up, or any n to the firsts, or any n to the seconds. So I'm all done. All right, for number 4, we have another addition problem. So we're going to add together these two polynomials. So again, just combine the like terms. So I've got a 7 and another 7, and I'm adding, so I can get rid of the parentheses entirely if I want. 7 plus 7 gives me 14, so that's the constants. Then I have 1 v to the second, and I have negative 7 v to the second. So if I have 1 and I subtract away 7, that gives me negative 6. So negative 6 v to the second. And then the last thing I have is this negative 8 v to the third, and then I have a 7 v to the third. So if I take negative 8 and add in 7, that gives me negative 1 v to the third. And there's my simplified polynomial expression. So next up, I'm going to do the product. So when I do the product, I just, FOIL or distribute, whatever you want to call it, with whatever number of polynomials that I'm multiplying together. So in this case, I just have 2 of them. So I'm going to follow the rules of FOILing or distributing. So I take the first number, 5x, and I distribute it into both numbers through multiplication. So 5x times 7x, 5 times 7 is 35, so I get 35x to the second power. 5x times 4, so 5 times 4 is 20, so I get a plus 20x. And then I take the second number, which is negative 1. I need to be mindful of the sign. Negative 1 times 7x and negative 1 times 4. Negative 1 times 7 is a negative 7, so negative 7x. Negative 1 times positive 4 is a negative 4, so negative 4. And then I'm just adding polynomial values together, so that means that I'm combining like terms. So I have a 20x and a negative 7x, and if I add those together, 20 minus 7 gives me 13, so I have 13x's. And then I don't have any other x squares, so I just leave that as 35x squared. And then I don't have any more constant values, so I just have minus 4. So after I multiply the 2 polynomials together, I get 35x squared plus 13x minus 4. So the same rules apply for these 2 polynomials when I add them together. I take each of the terms in here and I distribute them into all 3 of these terms. So if I take the x and distribute it in there, I get x times 7x squared, which would be 7x to the third power now. X times negative 2x, which would give me a negative 2x squared. X times a negative 4, which would give me a negative 4x. Now I take the 4 and I distribute that into all 3 terms. 4 times 7 is 28, so I get a plus 28x squared. 4 times negative 2 is negative 8, so I have a negative 8x. And then 4 times negative 4 is a negative 16. So now I'm going to combine like terms. So I don't have any more x to the thirds, so I just leave that as is, 7x to the third. I have a negative 2x squared and a positive 28x squared. So if I take 28 and subtract away 2, I get 26, so 26x squared. Then I have a negative 4x and a negative 8x. So if I have negative 4 and negative 8, if I add those together, I get a negative 12x. And then I don't have any other constants, so I just leave that one as is, negative 16. And there's my completed polynomial. So these are all of the operations of polynomials, and then also telling whether something is a polynomial or not. So the next thing that we're going to tackle is the synthetic division, and for that one, I'm going to go to a separate video.